Hello everyone, in this video we are creating some basic player controls like movement, jump and third person camera control. So let's get started. So here is our environment. I have created this environment using a free sample asset called Fantasy Forest Environment. You can download it. I will provide link in the description box so you can download it from asset store. Here is a player slot. This is just a game object, nothing onto it. Only scripts and character controller onto this game object, because in future we need a player graphic to represent our player. So here I'm using simple capsule. Okay, and I have created three scripts. One is controlling our mouse inputs and one is for our keyboard inputs, so player can move around by these inputs, and the last one is our player motor. It will handle all the movements and camera controls. Okay, so first let's open player inputs. Here we are inside our player input script. We need some required components, type of character controller and player motor, and here we will getting our player motor inside a wake function, and we are simply returning movement vector 2. Movement, I'll call it just movement, and new vector 2. This is just simple input dot get axis, horizontal and vertical axis, and returning it to player motor. Okay, there is our jump input, simply just input dot get key down dot keycode dot space bar, and here is our player motor dot jump input. Let's get into our player motor script. Inside player motor, here is our required variables. These are our required variables. Is jumping to know player is jumping or not. Okay, camera slot. Let me show you what is camera slot. This is our camera. Look at, this is simple game object. Camera is rotating around it, and just simply call it camera slot inside script, and there is our two scripts. One is our player input and the second one is our player controls, camera controls, and here is our camera controller component. Okay, now here is our player settings. I'll simply just tag it as serializable field, because we do not want to call it from any other script. So, and we also want to see inside inspector, so serializable field will provide us that functionality. So this is a float for moving speed of player. This is the camera settings, also serializable. All these fields are serializable. Float, camera sensitivity, and most of the logic here comes in jump settings, gravity, jump height, jump forward, applied force. I will explain it later. Okay, now air control and step down. Okay, I will also explain it later. Now velocity 3, vector 3, our velocity, and we will simply rotating our camera only on x-axis, and our player to rotate around y-axis. And this is our player input, which we are handling inside player input script, and I am referencing our all required components. Inside update function, I'm simply calling our jump input function inside our player motor script, player input scripts, and if we are pressing input function, pressing input in the jump input, then we simply call jump function. Okay, first we need to go inside the player movement, which I am I'm using fixed update for these player movements. uh, I explain it later. First we will know about our player movement. So here is our player movement logic. Okay, I'll simply create a local variable called movement and created two functions. There is two functions. One is with the capital M and one is with a small m. This is to move function. Let's go into this move function. This will return simply vector 3 and I will multiply our transform dot forward our player forward direction with the player input dot move dot y, which is vertical axis, and our horizontal axis to get our player movement vector, player movement vector. Okay, and simply multiply it by move speed and fixed delta time. Fixed delta time, I am multiplying it by fixed delta time because I am working with fixed update, and default value I think 0.02 maybe. Okay, you can also check it inside editor project settings inside, I think physics not sorry inside time. This is our fixed delta time, fixed delta time 0.02. Let me show you what I'm talking about. If I simply debug this, debug.log and dot fixed delta time, let's see what's the value of this. I think 0.02 is the value. Yes, here we go. Here 0.02 because this is fixed delta time. Okay, we are inside fixed update, so fixed delta time is always 0.02 by default. Now simply track it, and here is our vector 3 step down. Now I will explain why I'm using this variable and this vector 3. We are using character controller, and the character controller do not having functionality of gravity because character controller do not know what is gravity and all these things. So we need to tell our character controller to move down onto ground by this simple vector 3. Okay, and now we'll get this. Okay, so I'll simply multiply by vector 3 dot down, which is 0 minus 1 0. Okay, now we'll move on to our move function. Okay, now inside move function I simply feed two values because move function will take two parameters. Both are vector 3. So move function, let's move on to move function. Move function will take two vector 3s, one is for movement, one is for step down, and inside this I'll simply call this function of character controller called my character controller as controller, and simply add these two values to get our vector 3 because move function will take vector 3. Okay, now we will understand these. Okay, all these things. Jump function, let's see what happens inside this function. If we are not jumping then and pressing jump button, we simply turn for is jumping boolean to true, and velocity to our controller dot velocity multiplied by jump forward applied force. Now I will explain this inside Unity editor. What I mean by jump forward applied force. There 0.05 is our jump applied force, forward applied force, I press play and walk and I will jump, you see how he is moving in air. Okay, and I will also explain air control. Air control is when I am simply jumping and not pressing any kind of forward and backward key. So I will also control my player in air. Okay, this is our air control, and my jump forward applied force is this. When I'm moving and press jump, you'll see the velocity of this character not change. Let me explain deeper. Okay, if I will simply change it to 2 and put 2 inside this and press. Now see what happens. You see how it launches into air. So this is our applied forward force. I applied some extra force to player when he is jumping. Okay, so okay, now default is 0.5. okay, so this is our jump applied force, and the controller dot velocity, whatever the velocity of the controller, which is controller moving or not moving. Now there, this calculation I will explain inside sketchbook. Okay, some basic physics calculation. Okay, here is our ground, this is our player. Let me draw player quickly. He's our player and he's on ground and he jumps, and he's not on ground. Very weird looking character. This is our player when he press jump button. Now the height of the player. Now this is our height, player height. This is h height, and height is equals to y because he jumps towards y axis, so height is equals to y. So we don't know our initial velocity, and we know our velocity on the top of this line when we reach certain height, and here the velocity is 0 meter per second. 0 meter per second. Okay, now here we know our velocity is 0, and there is a free falling body, so we can calculate our average velocity. Okay, now avg equals to v0 plus v1 upon 2, and we know our velocity, not 0 1 is velocity 1 is 0, so we simply write average velocity equals to v0 by 2. Okay, and we also know velocity equals to displacement upon time. Here the displacement is our y, so delta y, this is our y, and delta y upon delta t. Okay, and here our y equals to height, so we will simply write v0 equals to h upon delta t. So velocity here, average velocity is our v0 upon v2, so we can simply write v0 equals to v0 upon 2 equals to height upon delta t. So I will simply write here v0 upon 2 equals to height upon delta t. and I'll simply take this and this, and let me explain further. And our acceleration, let me take acceleration, and acceleration equals to change in velocity upon time. So our velocity upon change in time. So here acceleration, where we are free falling body, and then acceleration goes to minus gravity, and gravity is nothing, just gravity equals to 9.18 meters per second square. Okay, you know this, you already know this. So minus g acceleration, because we are free falling body. So we calculate our velocity. So v1 minus v0 on delta t. So we know our v1 equals to 0, so minus g equals to minus v0 upon delta t, minus cancel out. We will get delta t equals to v0 upon g. So we will get our time, simply put here. So v0 upon 2 equals to height into gravity upon v0. So multiplied by v0 equals to v2 v0 square equals to 2hg, and here we get our equation. So v0 equals to root 2 g h. This is the equation. So there is this calculation. Okay, so that's why I'm using this method, that dot square root of 2 into gravity into jump height. Okay, I think you will get this point. Okay, now we are getting our velocity. Let's jump on to our if statement. If we are jumping, then velocity dot y minus equals to gravity into time dot delta time, because we need to interact with the gravity, because there in this case if we are not using this, our player is flying and don't come back home to ground. So y minus equals to gravity dot into time dot fixed delta time, and here I am using local variable, player displacement velocity multiplied by time dot fixed delta time, and then player simply displacement plus equals to calculate air control. I am calculating air control inside this function and returning vector 3. I simply multiplied our move function, which is this function, multiplied by air control divided by 100. Don't confuse, I just divided by, I want to deal with some smaller numbers for air control, so that's why I am dividing by 100. So now we will calculate our air control, then simply plus equals in our player displacement, and controller dot move, because we are jumping, so we need to call our controller dot move function and feed it our player displacement variable, and is jumping. We don't want right now to is jumping false, because goes inside this state, which is our movement state. So we simply reverse it by our ground controller dot is grounded. So when we are grounded, so this function is this statement is not called. Okay. logic, and here we are not grounded. In case we are falling through any edge, and also need this logic. We do not calculate our jump force inside this, because in case this we are using 0, because we need to fall onto ground, so that's why I simply zero it out. Now we are moving to our look camera. Here is all our camera control logic. So camera X rotation. This is just a simple float, and I'm clamping it in between -70 to 70, because we do not want to camera flip over. Okay, so simply clamp it. So camera dot x minus controller dot mouse controls dot y moment. This is our camera y moment. I'm moving my mouse to y axis. Okay, so we are minusing our camera rotation by this camera y mouse inputs, and here is our camera slot dot local rotation. We need to rotate our camera slot locally. So here I'm using lerp function because I need smooth rotation. So I'm using lerp camera slot dot our initial rotation and our final rotation, which is our which I am calculating here. Calculate camera x rotation, and simply give it a time. And I am also using method.lerp function to smooth out my player y rotation. Now I'm using method.lerp. Okay, now I'm simply rotating our player on the y axis and rotating around this axis. Okay, now all our function is covered. Then we will simply call these two functions inside our fixed update. Let's move to this. Here is my mouse sensitivity. I simply increased my mouse sensitivity inside this function because default is very small, using small values because I don't want my range to be more than 1. So I'm simply multiplied by 20. This is our mouse sensitivity, and this is our mouse inputs, and returning to our player motor. And this is nothing, just hiding our cursor when we are in play mode. Okay, so when we start our game, the boolean is true and our cursor is locked, and visibility is also false. And when we are in play mode, then we will press escape to see our cursor to stop the game, and also if we press L for lock to lock our cursor. Okay, that's it for our script. Let's hit play and see. Okay, this is all our logic working together. By character controller, we will move on to the slopes. In case we are using rigid body, this is not possible. Okay, that's why I'm using character controller for controlling per player, and I'm also using cinemachine. So this camera collision function is also available for free. We do not want to write any extra code to get this feature. Okay, let me show you my settings of cinemachine. This is my cinemachine virtual. I simply created a virtual camera, and inside follow and look at slots, I simply put this camera look at, and body type is third person. Damping 00 because I created my own smoothing, and that's it. There is our controller. In next video I will implement a character, a real character, and apply some animations onto our player. Okay, hope you like this video. If you like this video, hit like button and make sure to subscribe for more videos like this.